Welcome to the Bentley Systems training course, where we will show you how to understand the analysis and results in Staad Pro. In this video, we will be focusing on the analysis commands. We will provide a brief introduction to the different analysis commands that are available in Staad Pro, and we will show you how to review the results between a first-order and second-order analysis. When you have completed all of your modeling steps and are ready to specify your analysis command, you will go over to your page control area and select your Analysis and Print tab. By default, the Analysis tab will be selected and the Analysis Print Commands dialog will appear on screen. From this dialog, you would select one of the various different analysis types that are available, and we'll go ahead and discuss a few of them at this point. The first tab we're going to find is to perform an analysis. This will instruct Staad Pro to perform a linear elastic or stiffness analysis. Next, we'll find our P-delta analysis tab. This will instruct the program to perform a second-order elastic analysis that considers the effects of the applied loads acting on the displaced structure. This type of analysis is generally preferred by most building codes. This performs an iterative process, and this type of analysis also has the option to specify the number of iterations to be performed or to place a convergence tolerance on the displacements from successive iterations. There is also an option to include the P small delta effects, which will consider the effect of the applied loads acting on the deformed shape of individual members. Finally, this analysis also includes the option to include the geometric stiffness matrix, which modifies the member stiffness based on the applied loads. Adjacent to that, we have the Perform Cable Analysis command. This will perform a nonlinear cable analysis on a structure that contains nonlinear cable members. In addition to that, we also have the option to perform a direct analysis. This command will perform a direct analysis in accordance with Appendix 7 of the AISC 360 code. This method accounts for the second-order effects resulting from deformation in the structure due to the applied loading, imperfections, and the reduced bending stiffness of members due to the presence of axial loads. This analysis is similar to a P-delta analysis with the use of the geometric stiffness and small delta options that can be selected. However, this analysis calculates modifications to the stiffness matrix using the tau factors described in the AISC 360. We also have an option to generate floor spectrums. This will be used to request the calculations of floor and joint response spectra from time history results. This is particularly useful in the analysis of floor systems supporting vibrating equipment. This feature requires a license of the Advanced Analysis option. We also have an option to perform an imperfection analysis. This will consider the secondary effects of loading acting on members that have an initial curvature or camber, or an initial drift or an out-of-plumbness. This analysis is used on structures that have members with an imperfection specification applied to them. Adjacent to that, we have the command to perform a buckling analysis. This identifies the factor by which the loads in the selected load case should be increased or decreased if the factor is less than 1, such that the Euler buckling first occurs in any member of the structure. Lastly, we also have the Perform Pushover Analysis command. This will perform a static, nonlinear procedure in accordance with FEMA 356. This method, a lateral push load is applied to the structure and increases progressively according to a predefined load pattern until either the loading or the structural displacement reaches a prescribed level. This method considers the nonlinear behavior of the structure, allowing plastic hinges to form in the structure until the collapse mechanism is created. This technique is typically applied to seismic rehabilitation of structures. Now that we've discussed all the different analysis options available in Staad Pro, let's go ahead and see the difference in the analysis results when we specify two different analysis commands for the same model. We're first going to start with a linear elastic analysis. In a linear elastic analysis, no secondary effects will be considered. When a vertical load and a lateral load are combined, the results for the vertical load case will be added to the results of the lateral load case. Before we specify an analysis command for our sample structure, let's first review some of the loads that have already been applied. If I go to the General tab and the Load and Definition subtab, I will go to the Load and Definition dialog and expand my load case details section. Here I can see that in load case number 1 represents a vertical load of 100 kips that has been applied to the top of the structure. Load case number 2 represents a lateral load of also 100 kips that has been added in the global X direction. Lastly, if I take a look at load case number 3, this represents a load combination that basically combines load case number 1 with load case number 2. We are now ready to specify our analysis command, so I'll select my Analysis and Print tab in the Page Control area. In the Analysis Print Commands dialog, I'll select my Perform Analysis tab and then click the Add button to instruct the program to perform a linear elastic analysis. To perform an analysis, we will go up to our menu bar, select Analyze, followed by Run Analysis. Once the analysis is finished, we do want to ensure that there are no errors or warnings noted, and then we're going to go directly to our post-processing mode. Once in the post-processor, we can review the displacements and the reactions of the structure. First, let's review the displacements, and if I looked in my page control area, I would notice that the Node tab and the Displacement subtab are already active by default. Now let's take a look at the displacements of node number 2, which is at the top of the structure. If I take a look at the horizontal direction, which will be my global X direction, I can see that my vertical load is now causing 0 displacement at node number 2. If I took a look at my lateral load, I would notice that we have a 10.12 inch displacement, and if I took a look at my combination, it would be 10.12 inches, basically a direct result from load case number 2. Next, if I took a look at my reactions, I can review the reactions at node number 1. For my vertical load case, I can see that the reaction is basically equal and opposite of the load applied, which is 100 kips, and you will see that no moment was induced as a result of this load. For load case number 2, I can see that the reaction is equal and opposite for the force component, and then it did cause a moment reaction, which is basically the force times the height of the column. Lastly, if I take a look at my load case number 3, which is my combination case, I can see that my results have basically been added together to achieve my horizontal component of my reaction, my vertical component, and then my moment, which is exactly equal to the moment that resulted from load case number 2. Next, we will show you how to specify a p-delta analysis command, and what you're going to notice is that the results will be a little different even though we're going to be using the same model. So in a p-delta analysis, Staad Pro will consider the second order effects due to the displacement of the structure when calculating the reactions. This basically means that when the structure sways as a result of the lateral load being applied, that the vertical load or the gravity load will also induce a small moment at the base of the columns because of that sway or that deflection of the column. To specify a p-delta analysis, we will go to our Analysis Print tab in our Page Control area and select the p-delta analysis tab. Now, as we mentioned earlier, we can use the geometric stiffness matrix and include the effects of small delta. But for this training, to keep things simple, we're just going to include p large delta. Once you specify all of your commands, you can click the Add button, followed by Close, and now we've instructed Staad Pro to perform a p-delta analysis instead of the traditional linear elastic analysis. I'm going to save my model and then again re-perform the analysis. Once my analysis is complete, I'm going to proceed to the post-processing mode. Once in the post-processor, I can again review my displacements and my reactions. What we're going to notice at load case at node number 2 is that for load case 1, which is our vertical load, we still do not have any horizontal displacement of the structure. We are seeing the same exact horizontal displacement of the structure for load case number 2, which is our lateral load case, same exact as was performed during the regular perform analysis command. But what we're noticing now is if we go to the combined result of load case number 1 and load case number 2, we have an additional deflection here that is resulting from that second order analysis that was performed. In addition to that, if I went to my reactions tab over my page control area, I would see that on my vertical load, I still have just my equal and opposite reaction. Same goes for my lateral load. But if I take a look at the combined loads, the combined effects of gravity load or vertical load with the lateral load, I'm going to notice that I have some additional force in my x direction. I have the same force in my y direction, but also what I'm noticing is I have an additional moment. Basically what happened was my vertical load times the displacement of the structure, which is the displacement of the structure from load case number 2, which is about 10.12 inches. If I take that and multiply it by my 100 kip gravity load, I will get the additional 84.3 foot kips that induced an additional moment reaction at the base of this column. At this point, this completes our process for performing a linear elastic analysis and a p-delta analysis in our sample model, as well as understanding the different analysis commands.